Okay, so we're going to be dividing polynomials by a binomial. We are going to use factoring to do that, so that's why we learned how to factor first. So the way that you do this, there are 3 steps. You first factor the numerator. Step 2 here says cancel out common factors. I prefer the word divide out. So instead of cancel, we're going to say that is going to be divide, right? So when we are factoring, we are dividing. So we're going to divide out, not so much cancel. It's going to look like canceling, but technically it's dividing. And then the remaining factor is your answer. So we're going to use this example over here to start with. So we have x squared plus 7x minus 8 divided by x minus 1. So we are going to first factor the numerator. Remember, when we factor, we always look for 2 things. First, a greatest common factor. So step 1 would always be look for GCF first, greatest common factor. If it doesn't have a greatest common factor, then you can move on. If it does, divide that out, and then second step is then to tic-tac-toe. Again, tic-tac-toe is just the method that we use for factoring. Okay, so looking at this one, we have x squared plus 7x minus 8. I don't see a greatest common factor here. I cannot take an x out because this 8 doesn't have an x. I can't divide out a common number because the coefficient here is 1. So at this point, we're just going to tic-tac-toe. So I'm going to draw my tic-tac-toe grid. Okay, so x squared, our first term, always goes in the top left. So x squared in the top left. 7x, our middle term, always in the bottom right. Negative 8 in the top middle. So we're looking now for factors of x squared and then factors of 8. Well, here's the cool thing. We're dividing by x minus 1, and they kind of already told you, well, this has to be one of them as long as this is factorable. So as long as this is factorable, this should be one of your terms. So let's try that. Let's put this in and then see if that works. If it doesn't work, then that tells us this might not be factorable, or it's definitely not divisible by x minus 1. So I'll show you what I mean. I'm going to take the x minus 1 and I'm going to plug that in. Well, they just told me x minus 1 should be a factor. So let's see if I can make that work. Let me go ahead and circle that as well. So if I know that the first one here is x, then I know this also has to be x because x times x is x squared. If I know that this is negative 1, then this has to be positive 8 to get negative 8. So negative 1 times positive 8 would give me negative 8. Okay, so then I can multiply across. So x times 8 is going to give me 8x. X times negative 1 is going to give me negative 1x. And then I just want to verify, is 8x minus 1x 7x? Yes, it is. So x minus 1 is one of my factors. The other factor is x plus 8. So we're going to rewrite our polynomial, or our numerator here, with our 2 factors. Let me zoom back out so I can see that. So my numerator is now going to be x minus 1 times x plus 8, and we're dividing that by x minus 1. So what you should see then is, well, I have x minus 1 divided by x minus 1. When I divide anything by itself, that simply is just 1. So this is where we're dividing that out. Again, the notes originally said cancel. I kind of think it does look like it's canceling to you, but it really is just dividing out to give you a 1. So our answer then is going to just be what's left. So our answer that's left is just x plus 8. Okay, so let's do a couple of more. I want to do a couple that have greatest common factor and then a couple that don't. So let's look at... we'll do another one that's kind of like that one. So starting with number 1, x squared minus 10x plus 21. So first, look for greatest common factor. There is no greatest common factor here. We go straight to tic-tac-toeing. So we're going to tic-tac-toe this numerator, and we're going to use this denominator to help us out and see if that will get us closer to our answer. So I'm going to draw my tic-tac-toe grid. And I do that because there is no greatest common factor, right? So we first look for greatest common factor. All right, let's fill in our tic-tac-toe grid. So we have x squared in the top left, minus 10x in the bottom right, 21 in the top middle. And then they gave us x minus 7. If this is factorable, then x minus 7 should be one of the factors. So we're going to put x minus 7 in here. I'm going to go ahead and circle it also. Okay, so now we're looking for another factor to try and make this work. Well, if this is x, this bottom one has to also be x because x times x is x squared. If this is negative 7, then this has to be 3 to make positive. Actually, it has to be negative 3. I almost messed up there. That has to be a negative 3 because negative 7 times negative 3 would give us a positive 21. So then we're going to multiply across to see if we can verify that. So x times negative 3 is negative 3x. X times negative 7 is negative 7x. So then we just want to confirm, is negative 3x minus 7x negative 10x? And it is. So these are going to be our two factors for our numerator. So we're going to rewrite our numerator as x minus 7 times x minus 3 divided by, now our problem has x minus 7. This step is really important that you rewrite this numerator as the two binomials. I know at this point you might already know, well, the answer is going to be x minus 3, but I think this is going to be really important as you move into geometry and algebra 2. So please write this step. I get that it's just a little more time consuming, but please do write that step. This is also how you show your work. You draw your tic-tac-toe grid. This is how you show your work. What we see is, well, x minus 7 and x minus 7 are the same thing. Dividing those will give me 1. Again, they just divide out. So our final answer is just going to be x minus 3. Okay, let's look at number 3. It's a little bit different. So number 3, we only have a binomial here, so that's a little strange, right? But you should remember last week we talked about this one. This is actually a special case. Hopefully you remember that special case when we're subtracting and it's two perfect squares. That is a difference of two squares. So you don't have to tic-tac-toe this. You could tic-tac-toe this if you plugged in a 0y in that middle, right? You're missing the middle term, so you could plug that in. Instead, if you know that it's difference of two squares, you should be able to follow the pattern that's on our reference chart. So remember, on our reference chart, it shows us how to do this. For the middle term to cancel, right? Remember, if the middle term cancels, they have to be opposites. So to get this, we just take the square root of each of these. So the square root of y squared is y. The square root of 25 is 5. That's going to be our two pieces of our binomials. And then, again, for the middle piece to cancel, these need to be opposites. So one of them is going to be positive, and one of them has to be a negative. So y plus 5 and y minus 5. Again, this is a difference of two squares. This is a difference of two squares. This is how you factor that. We're going to divide that by the y plus 5 that was already there. Again, you could still tic-tac-toe this. No harm in doing that, except it just takes time. Okay, so now we're looking for common factors in both our numerator and denominator. You should see this y plus 5 is both in the numerator and the denominator. So anything divided by itself is 1, so we can just basically take those out. So our final answer is just going to be y minus 5. Okay, let's look at then number 4. So number 4, I have 2x squared plus 16x. So this also looks a little different. So I would first look, is it a difference of two squares? Well, I automatically know it's not because this is not a difference and 2 is not a perfect square. So no. How about we look for a greatest common factor? Actually, that should have been my first step. So is there a greatest common factor between 2x squared and 16x? Yes, there is. So when I have 2x squared, I can factor out a 2x. So essentially, I'm taking this 2x squared plus 16x, and I'm going to divide out 2 and x, right? Both of them have an x, and they're both even, so I can divide out a 2. So remember when I do that, I put the 2x in the front. That's what I'm dividing out. What's left over goes in parentheses. So 2x squared divided by 2x is just x, plus 16x divided by 2x is 8. So I just factored the numerator using greatest common factor. I did not need to tic-tac-toe that. I have a binomial here, so that tells me I don't need to tic-tac-toe it either. So I'm going to divide that then by The denominator originally was x plus 8. After we rewrite our problem like that, we simplified it. So now we're looking for common factors. So we have x plus 8 in our numerator. We have x plus 8 in our denominator. So these are common factors. Anything divided by itself is 1. So 2x is going to be our final answer. Okay, let's do one more like that. We're going to do number 6. So number 6, we have 10x minus 15. So again, you might think, oh, this is a difference of 2 squares. Well, again, it's not. It is a difference, but this is not a perfect square. 10 is not a perfect square, and 15 is not a perfect square. So not a difference of 2 squares. At this point, then look for a greatest common factor. So is there a common factor between 10 and 15? Yes, there is. It's 5. So I'm going to do this one a little bit differently. Instead of like writing it out to the side, I'm just going to really small, right? I'm dividing by 5 right here. That 5 goes on the outside. In parentheses, we put what's left over. So 10x divided by 5 is 2x minus 15 divided by 5 is 3. Divided by 2x minus 3. So now we're looking at this simplified version of that. So I have 2x minus 3 on my numerator, 2x minus 3 on my denominator. Anything divided by itself is 1. So we can basically take those out. We're left with just 5 as our answer. Okay, so hopefully that gets you started. We'll do some more in class, and we'll see how that goes.